Fred's birthday was on a Monday and was exactly 37 days before Pat's birthday. Julie's birthday was 67 days before Pat's birthday. On what day of the week was Julie's birthday? So, many ways of doing this question. I guess we'll just do it the old-fashioned way, which is just write out the calendar. And then let's first talk about Fred, right? So Fred, his birthday's on a Monday. So he's down here. And I'll just write F for Fred. And then 37 days before his birthday is Pat. So if you subtract 7, you'll get right back to this exactly 1 week before. So it's 37 days. But if you go 30 days, which is exactly 7 days less, you get right back to the Monday. Similarly, 23, 16, 9, and 2. And then we have to go 2 more to get to Pat. So 1, and then Pat's birthday, which would be right here. So Pat's birthday is on a Saturday. You see how I did that? Just going back multiples of 7. And I had to go back 37 days. Now I do the exact same thing to figure out what day of the week is Julie's birthday, and she is 67 days before Pat. Okay, so the same thing, subtract multiples of 7. So we've got 60 and 53, 46 and 39, 32, 25. Let's see here, 18, 11, and 4. So this is 3, this is 2, this is 1, and this is Julie's birthday. So Julie is on a Tuesday. So number 18, the answer is D. Harry the hamster is put in a maze and he starts at point S. The paths are such that Harry can move forward only in the direction of the arrows. At any junction, he is equally likely to choose any of the forward paths. What is the probability that Harry ends up at B? All right. Well, how do I want to do this here? Do I want to use the diagram? It might get a little messy. Sure. I think you'll be able to see it. Okay. Let's start right here. At that point, he's going to go either here, here, or here. And each of those is with equal probability, equally likely, it says in the question. So he can go here 1/3 probability, here 1/3, and here there's a 1/3. Equally likely to go each of those paths. Now, once he gets to here, he can go either this way or this way, and each of those are equally likely. So he can go this way 1/2, and this way 1/2. Okay? And then when he gets here, there's only one way to go, and that's here, and that's 1. A probability of a full 1, 100%. And then once he gets to here, it's 1/3 to go here, 1/3 probability of to go here, and 1/3 probability to go down to D. All right, now let's circle the probabilities that we are interested in. We want to get to B, right? Okay, we can do that in the following ways. The first way is this one and this one. The next way is this one and this one. And the last way is this one and that one. Okay, so the first one is 1/3 times 1/2. Add to it the next one, which is 1/3 times 1. And add to it the last one, which is 1/3 times 1/3. So that gives you 1/6 plus 1/3 plus 1/9. Now let's add these. Common denominator is, I believe, 18. And then that would mean 3, 6, and 2. And that gives me 11/18. And therefore, number 20, the answer is C. At Gauss Land Olympics, there are 480 student participants. Each student is participating in 4 different events. Each event has 20 students participating and is supervised by one adult coach. There are 16 adult coaches, and each coach supervises the same number of events. How many events does each coach supervise? There are 480 students, and each of them participates in 4 events. So that means there are 1,920 students in all the events. Now, there's 480 students, but a lot of these are counted 4 times. So these are non-unique students in all events. Okay? But each event has 20 students. So you take all of these students and you divide by 20, and that gives you 96. And this represents the number of events. This question is a little bit confusing, takes a little bit of thinking in my opinion, especially at the grade 8 level. Okay, so I hope this is clear. Okay, so if there's 96 events, there are 16 coaches. So 96 divided by 16 is how you figure out how many events each coach supervises. 96 divided by 16 is 6. So number 19, the answer is C. How many 3-digit positive integers have exactly one even digit? Well, my 3-digit number, I have 3 possible scenarios because I can only have one even digit. Emphasize that word, exactly. So let's start with the first scenario where my even digit is here in this position, the units digit position. Well, what are my even digits in terms of my possible choices? 0, remember 0 is even, 2, 4, 6, or 8. So that means I have 5 choices for this units digit. Now this guy cannot be even, right? Because I can only have one even digit. So that guy obviously has to be an odd number. So my choices are 1, 3, 5, 7, and 9. So I've got 5 choices. And very similarly, this one can also only be 1, 3, 5, 7, or 9. 5 choices. So I multiply these to get the total number, and that's 125. Now I've got 2 more scenarios. The next is when the even number is here. Well, if the even number is there, it's pretty much the same thing as what I just did. This is going to be 2, 4, 6, or 8 as possible choices. And these guys, 1, 3, 5, 7, 9, and 1, 3, 5, 7, 9. So 5 possible choices for that, 5 possible choices for that, and again 125 when you multiply them all out. Now this is slightly different because you might be tempted to think this scenario is identical. It's not. The reason is because now I want the even number to be here. And if the even number is here, I cannot put a 0 because if I did, it's not a 3-digit number. It's a 2-digit number. So I can only put either 2, 4, 6, or 8. And then these ones are the same. I can put 1, 3, 5, 7, or 9. So the number of choices for the first first digit, which is the hundreds digit, 4 this time. But then for the tens digit and for the units digit, it's 5 and 5. So this is slightly different. This is 100. So the total, I have to add these 3 guys, 125, 125, and 100, is 350. So the answer for number 19 is A. Ahmed chooses 2 different items for a snack. His choices are an apple, an orange, a banana, and a granola bar. How many different pairs of snacks could he choose? For the first snack, he has 4 choices. For the second snack, because they have to be different, he has only 3 choices. Multiply and you get 12. Well, 12 is not one of the answer choices. Why is that? Because you have to divide 12 by 2 to get 6. Why do you have to divide by 2? Well, let's say he chose an apple and a banana. Well, if he had also chosen a banana first and an apple second, this is the same pair. So this 12 double counts. So that's why you have to divide by 2 to get 6 unique pairs. And therefore, number 13, the answer is D. The whole numbers from 1 to 1,000 are written. How many of these numbers have at least 2 7s appearing side by side? So the first scenario will be if you have a number of this form where you have 7, 7 like that. And then the other digit can be anything. And that digit can be anything from 0 to 9. So that's 10 possibilities, right? So there's 10 of these guys. 10 numbers that look like that. Then the other possibility is if you have a number like this, 7, 7, where this can be anything from 1 to 9, right? Can't be a 0 because that would not make it a 3-digit number. Because I'm initially talking about 3-digit numbers. So how many of these guys do you have? Well, 9 of those. And then 2-digit numbers, that's relatively easy. There's only one possibility, and that's 7, 7. So there's one of those guys. Now keep in mind, they are saying at least 2 7s. So you can also have 3 7s. And 3 7s, well, there's obviously only one way of doing that. So there's one of those. So in total, I've got 10 plus 9 plus 1 plus 1. And that is 21. But this question is a bit tricky here. I think a lot of hearts have been broken because of this question, because 21 is not the right answer. You say, why? It seems like everything made sense, right? Because we overcounted. Overcounting is a very common mistake on math contests. And it's, like I said, it's very disappointing because it often happens on easy questions that you definitely know how to do, but you overcount it. Why did we overcount? Well, because in this category, one of the numbers is 777, right? It's when this third digit becomes a 7. In this category, one of the numbers is also 777, correct? When one of these is a 7. And then over here, we have that 777 again. So this number, 777, was counted 3 times. So we have to subtract 2 of them from our total. And therefore the answer is 19. Okay, so don't feel bad if you got this wrong. Number 19, the answer therefore is E. A ladder has 5 rungs. Elizabeth can climb up by 1 or 2 rungs at a time. How many different ways can she climb up to the 5th rung of the ladder? This question is the equivalent of this equation. 1 times x plus 2 times y is equal to 5. Because you can reach the top rung, which is 5 steps basically, with some combination of 1 or 2 rungs, I guess. So we want integer solutions. And very quickly, you will realize that the only ones are 5 and 0, 3 and 1, and 1 and 2. So I say, okay, well, there's 3. That's the answer. But 3 is obviously not one of the answer choices. Then why is that? Because each of these perhaps can have different permutations. So let's start with the first one, 5, 0. The only way to do that is 5, 1 steps. That's the only way. So that only has one way. But how about 3, 1? 3, 1, I think that's going to be done in a few ways. You can have 1, 1, 1, and then a 2-step. Or you can put the 2-step here, or the 2-step here, or the very first step could be two rungs. So there's 4 ways of doing that. And then the 1, 2 combination of 1, 1 step and 2 steps, that can be either 1, 2, 2, 2, 1, 2, or 2, 2, 1. So how many did I create? 1, 2, 3, 4, 5, 6, 7, 8 ways. And therefore number 16, the answer is E. A test has 10 questions. Points are awarded as follows. Each correct answer is worth 3 points. Each unanswered question is worth 1 point. Each incorrect answer is worth 0 points. A total score that is not possible is. This question reminds me of a scenario. I knew a student who scored the highest score in all of Canada on one of these Fermat contests a few years ago. But when he got his score back, it was 145, right, out of 150. And he couldn't understand how did he get 145 because he knew all the answers. He knew when he handed in his paper that he scored perfect. He was convinced of it. But when he got his score back, he got 145 out of 150. And for the longest time, he couldn't understand how did that happen. Because if you miss one of the hardest questions, the last 5, your score would be 144 if you answer it blank. Or if you answer it incorrectly, your score will be 142. So he racked his brain, and finally he realized that it was one of the first few questions, the first 10, that he got wrong by accidentally circling the wrong answer. And if you do that, it costs you 5 points. So as you can imagine, he was quite heartbroken. So this question actually reminds me of that. It's very similar. This time they've got 10 questions, and they've given you a very similar kind of point system. Which of the following scores is not possible? Okay. Well, I kind of immediately, by looking at the answer choices, I can tell, just because I've done so many of these math contests, but I'll explain it. Let's say you get all 10 correct, right? Well, you'd get 10 times 3 points for each correct. That's a 30-point total. Let's say you have 9 correct, and you have 1 question that you left unanswered. That would mean you'd get 9 times 3 points for the ones you got correct, plus 1 point for that 1 question you left unanswered. This is a score of 28. All right? How about you have 9 correct and 1 question that you got wrong? Well, you'd have again 9 times 3, but for the wrong question, you won't get any points. You get 0 times 1, and that's 27. And then so on down, right? 8 correct, 1 unanswered, and so on. Notice there's 1 score that's not possible. It is 29. There's no way of getting 29 with this scoring system. So number 18, the answer is E. For how many pairs mn with mn integers satisfying m less than 100 and greater than 1 inclusive, and n is between 101 and 205 inclusive, is 3 to the power of m plus 7 to the power of n divisible by 10. All right. 3 to the power of m plus 7 to the power of n is divisible by 10. Well, how do we approach this? We have to look at the units digit, the last digit, or the ones digit, whatever you want to call it. So the first thing I'd like to do is illustrate that there's a pattern, and that pattern definitely helps us. So if I write down the units digit for the first few powers of 3, you'll see a pattern. I'm just writing the units digit, the last digit. 3, 9, 7, 1, 3, 9, 7, 1. And as you can see, it just keeps on going like that, 3, 9, 7, 1. And then in a very similar way, if I write the units digit for powers of 7, 7 to the power of 1, 2, 3, and so on, I hope that there is a similar pattern that will help me. Again, let's just write the units digit. 7, 9, 3, 1, 7, 9, 3, 1. And there is a pattern. So there we go. Now, how do I get something divisible by 10? If the last digit is 0, so whatever this number is, some big number, if the last digit is 0, it will be divisible by 10. How do I get the last digit to 0? Well, look at the combinations. I only have to look at these numbers and these numbers, because everything else is the same. Okay, well, if 3 to the power of m and 7 to the power of n are added, we want it to add up to 10. That will make that number have a 0 at the end, and therefore it means it's divisible by 10. Well, I can have a 3 and a 7. So I can choose this guy and this guy. That would do it. I can have a 9 and a 1. These are the units digits only. A 7 and a 3 and a 1 and a 9. These possible combinations will do it. Okay, but we have a long list here for both. We have a lot of choices, so we got to figure out how many choices. I want the units digit to be a 3 in this first scenario. So that means the exponent will be either 1 or 5 or 9 if you continue that pattern, 1 dot dot dot. And then I want the units digit of this to be 7. So that means the exponent of 7 would be either 1 or 5 or 9 and so on, right? So 1, 5, or 9 and so on. And any of those would satisfy the fact that 3 plus 7 is 10, and that would make it divisible. But I have to figure out how many are there. Well, m is going from 1 to 100. So how many of these numbers are between 1 and 100 inclusive? Well, you can count or you can use whatever system you want. The way I usually do it is I just take the last number and divide by what's going on here, and that it's going up by 4 every time. So they're basically, you have to see how many times do we get this multiple of 4. But you're adding 1, so it's a little bit complicated. Not extremely, but you just have to think of it that way. So what you can do is you can just add something to make it a multiple of 4. I just have to add 3 to 1 to make it a multiple of 4. If I add 3 to 1 becomes 4, which is a multiple of 4. So I'm just going to add 3 to 103. So 103 and then divide by 4, and that gives me 25.75. So that means there's 25 numbers in here that are in this pattern. And you do the same sort of story, but this time n is a little bit different. N is between 101 and 205. So we have to figure out the same story for 205. So add 3. So 208 divided by 4. And that would give me exactly 52. But remember, I'm starting at 101. So all the ones until 100 that I got here, I've got to subtract. So it's actually 27. It's 52 minus 25. So there we go. And then, of course, I'd have to multiply these to get the total combinations, which in this case would be 675. All right, so let's do the next one. For m to be 9, that means the exponent is 9. Sorry, the units digit is 9. The exponent can be either 2 or 6 or 10 and so on, right? So 2, 6, 10, dot, dot, dot. And then similarly, if we want the units digit to be 1 for a power of 7, that means we want the exponent to be either 4 or 8 or 12 and so on. 4, 8, 12, dot, dot, dot. And now the same story, we have to now figure out how many of these are there. And by the same sort of principle, if you do all this, you get 25, and here you get 26. Same story here, it would be either 3 or 7 or 11, dot, dot, dot. And then here you would have either the exponent would be 3 or 7 or 11, dot, dot, dot. And here this is 25, and here it's 26. Keeping in mind that my m is between 1 and 100, and my n is between 101 and 205. And the last one, we want the units digit of 3 to the power of m to be 1. So that means the exponent has to be either 4 or 8 or 12 and so on. So 4, 8, 12, dot, 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 any one of those. And we want the units digit to be 9 for any power of 7. So that's going to be either 2 or 6 or 10 and so on. So now we have to figure out how many of these are there between 1 and 100. And that's simple now because you just divide by 4. So that's going to be 25. And then this one, you will add 2 and then divide by 4. So it'll be 207 divided by 4. And then I've got to subtract the fact that it's only going up from 101. So the first 100, add 2 to that, and divide by 4. And we're only interested in the integer values, so it's 51 minus 25, which is 26. And just like before, we have to multiply these guys. 25 times 26 is 650. This also gives me 650. And this also gives me 650. So in total, 675 plus 650 plus 650 plus 650, and that total is 2625. Therefore, number 20, the answer is E. A square has side length 5. How many different locations can point X be placed so that the distances from X to the 4 sides of the square are 1, 2, 3, 4, 5? Let's talk about one such square, and then we will see how many different ways we can do this. From the answer choices, one thing is for sure, that the answer has got to be a multiple of 4, because all of them are multiples of 4. So let's give a first scenario. Let's say we have a line that is approximately here, and I'm going to draw a line from here to here, and then I'll explain what I'm doing. So the square has a side length of 5, right? So if I chop it up into 1, 4, 2, 3, like this would work. This point would be my X right there, and that X is 1 from this side, it's 4 from this side, it's 2 from this side, and 3 from this side. So that works. I've got 1 so far. But this can be alternated in a few ways, right? The other way is, of course, to flip the numbers. Instead of 2 and 3, we can do 3 and 2. So that means the line would have to go a little bit lower. And, this is not exactly drawn to scale, but you guys get the idea. So, for example, this is now 3, and this is 2, and this is 1 and 4. So as you can see, my X is now here. It's in a different spot. Well, I can also do the same kind of story by flipping the 4 and the 1. So instead of having it like this, I could have it like this and like this, approximately. And the lines would be 4 and 1, so here or here. And as I previously mentioned, don't worry that this is not drawn to scale. I just wanted to show you the numbers. 4, 1, this is 2, 3, 4, 1, and this is 3, 2. So I've got X and X. Correct? So I'm tempted to choose 4, but I have a hunch that it's more than 4 since that's the second lowest. Okay, not a problem. How do I get another set? Well, in these first 4, I had put the 1, 4 in the horizontal position, right? Now, I'll put the 2, 3 in the horizontal position. So these guys will be divided 2, 3. And that should be able to do it. So this is going to be 2, 3. So this will be 1, 4, like this. So for example, this is 2, this is 3, this is 1, and this is 4, like that. And therefore this is X right here. And in a very similar way, I can flip the 2 and the 3 so that we have the 3 here and the 2 there, and the 1 and the 4 like that. So again, I've got a different X. And I can do the exact same thing this time, but I'm flipping now the 4 and the 1. So instead of the 1 going on top and the 4 going on bottom, we put the 4 on top and the 1 on the bottom. So these types of scenarios. This is now going to be 2 and 3, and this will be 3 and 2. So label these to illustrate what I mean. This is 4, this is 1, and this is 2, this is 3. This is 4, this is 1, this is 3, this is 2. So again, I've got X and X. And if you look at these all, you'll see all of them are different with regard to where X is. So therefore, I created 8 different scenarios, and therefore number 20, the answer is D.